Hey guys, welcome back again. We are still dealing with our series of ratios and proportions and solving equations surrounding them. There's so many ways to do and solve problems with ratio and proportion. They're so helpful. Don't you know you can determine how much paint you need to paint a room without going to purchase the paint and painting the room? And finding out that you've got too much paint or not enough paint? So many ways. You can make lemonade and determine if you need 4 lemons and 1 cup of sugar. What happens if you use 12 lemons? How much sugar do you need? And how much water do you need? There are ways you can figure out the answers without actually doing the actual work. We can figure it out using paper and pencil. So ratios and proportions are so very, very important. They help us with our money. They help us solve problems without actually doing and purchasing the materials ahead of time. Okay? So they're useful, and that's why we're going to use them with our board and with our lessons today. First thing on tap is to have you compare each fraction using the less than, greater than, or equal to symbol. Put it right between the 2 fractions as we compare each pair. Put the symbol right there. Which one is larger? Is 5/3 larger than 3/5? Is 1/3 larger than 5/15, or is it smaller? Or is it equal to? Is 4/9 greater, less than, or equal to 2/3? Is 14/35 greater than, equal to, or less than 14/25? As usual, we're going to give you 2 minutes to figure it out. Put in your answers. We'll be right back. One more minute. Okay, we're getting ready to review. We're looking at 5/3 and 3/5. Let's compare. Which one is larger? Well, there are a number of ways we can work it out. We can simplify it. We can get the same denominator. So many different ways. And then it'll be easy to compare. Let's look at it. For this particular one, I want to use your number sense. I want you to say whether this is larger than 1 or smaller than 1. Anytime you have a numerator that's larger than your denominator, that whole fraction is larger than 1. Okay? If I were to divide here, 5 divided by 3, it would be more than 1. All right? As a matter of fact, it's 1 2/3. Compared to 3/5, is this greater than 1 or less than 1? You have to realize that 5 over 5 is equal to 1. So 3 over 5 is less than 1. So if this one's greater than 1 and this one's less than 1, which one do you think is bigger? The one that's greater than 1 is bigger. 5/3 is larger than 3/5. That's one way to work it out. Let's look at another way. I can get a common denominator here using the CD for common denominator. I can create two fractions with the same denominator. Create an equivalent fraction to 5/3 is equal to, say, how many 15ths? How many 15ths? What did I do to the 3 to get 15? I multiplied by 5. Do the same thing to the top. Multiply by 5, and it's actually equal to 25 over 15 is 5/3. Now let's do that with the 3/5. Is equal to how many 15ths? Using that same denominator. What did I do to the 5 to get 15? I multiplied by 3. Do the same thing to the numerator, and we get 9. So now I'm comparing 25 15ths compared to 9 15ths. And of course, 25 15ths is the larger. So when I compare 25 15ths to 9 15ths, I know that 25 15ths is larger than 9 15ths. Okay, does that make sense? All right, we're still looking at number 1. We got a common denominator. First, we looked at it and we determined 5/3 is more than 1. 3/5 is an even 1. So that's obvious that 5/3 is larger than 3/5. Or we can get the same denominator and compare the numerators. And we know that 25 15ths is larger than 9 15ths. Okay? Two ways of working out number 1. Number 2, I'm comparing 1/3 to 5 15ths. In this example, I'm seeing two ways of working this out. Okay, it's always two ways, at least two ways. That's why I love math, because you can do it differently and get the exact same answer. That's what makes math so much fun. But at any rate, when I look at this one, I want to reduce. I want to reduce. I see a common denominator. I see a common factor here. And I can reduce it. And then I'll be comparing 1/3 to, let's factor out or divide out the common factor. I see 5. I can divide 5 here. I can divide 5 here. 5 divided by 5 is equal to 1. 15 divided by 5 is equal to 3. Now, since these are equal ratios or reduced fractions, I'm now comparing 1/3 to 1/3. And 1/3 to 1/3, they are equal. So my answer here is an equal sign. Okay? 1/3, when I compare 1/3 to 5 15ths, they're absolutely equal. So what did we do in this case? we reduced the fraction and then compared them. 5/15 actually reduces to 1/3. And then when I compare 1/3 to 1/3, it's equal. Let's look at number 4. Number 4, I'm seeing, oh my, I am seeing 2 ways of working this one out, at least 2 ways. Let me share this strategy with you. Don't you know how we were cross multiplying and we were bringing our arrows down? Well, students, there's a little trick to figure out which fraction is larger by upward crossing. Crossing upward. As I shoot upward, I get 12. That represents this fraction, in a matter of speaking. As I shoot upward this way, I get 18. That represents this fraction. Guess which one is larger? 2/3 is larger than 4/9. Because 18 is larger than 12. So the answer would be 2/3 is larger. Does that make sense? So we've got another strategy of how to compare fractions and determine which one is less than, greater than, or are they equal to. Okay? With that upward cross. It's all in the cross. Let's look at number 4. Another strategy of comparing fractions. I'm comparing 14 over 35 to 14 over 25. And my hint is to divide 7 and divide 7. And I also have to make sure my little division dots are clear and can be seen. So this is actually going to be equivalent to, this fraction 14 over 35 is equivalent to 2 fifths. 2 fifths, 35 divided by 7 is 5. 14 divided by 7 is 2. Now I can compare that equivalent fraction to 14 over 25. And which one is larger? Now I can shoot it up, my upward x, my upward multiplication symbol, and determine which fraction is larger. I shoot it over here and I get 50 to represent my left fraction, and I shoot it over here and I get 5 times 14. I'm going to use another strategy to refresh your memory. I'm going to multiply using the distributive property. And we've talked about this before, and it is important to bring it up. So allow me a sidebar. Dealing with the distributive property. I need to multiply 5 times 14. That's 10 plus 4. Because 10 plus 4 is 14. 5 times 10 plus 4. 5 times 10 is 50. Plus 5 times 4 is 20. The answer is 70 without mistake. So I shoot up over here and I get 70. When I compare 50 and 70, guess what, guys? This fraction is larger. 14 out of 25 is larger than 14 out of 35. Okay? Make sense? When I shoot it out of here, I get 70. When I upward angle this one, I get 50. 70 is larger than 50. So therefore, 14 over 25 is larger than 14 over 35. Make sense? Plenty of ways and strategies to do our mathematics. All right, so with that being said, are there any questions? If you've got a question, please don't hesitate to ask me. You can text, you can send in a request, you can make your request known, and we will see to it that you get the right answer. All right? Because math really does matter. Today we're going to talk about the importance, as we mentioned, of proportions and being able to solve problems, real life problems using math. Okay? Here we go. Our first problem of the day will be this. You will need 4 scoops of mix and 10 cups of water to make lemonade. 4 scoops of mix and 10 cups of water to make lemonade. And you know lemonade is good when it's good. But if it's too tart or too sweet, it's a mess. It really is. It can be really good or it can be a bitter mess. So we want to make sure we get the right mixture. So if we have 4 scoops of lemon mix and 10 cups of water. 10 cups of water. Will 12 scoops of mix and 30 cups of water give us the same taste? We can solve this problem using ratio and proportion. Let's discover how to do that. I'm going to turn this into a ratio of scoops to water. So my S to W. My first mixture will be 4 scoops to 10 cups of water. My next mixture will be 12 scoops to 30 cups of water. Will I be able to get the same taste? In other words, are these ratios equivalent? If they are, then I can expect the same taste. If they're not, then I'm going to make a mess. But it's better to make a mess on the paper so I can erase it rather than actually stirring up all of those scoops in water and 12 scoops and more water and then tasting the different ones, and it's like, ew, I'm going to have a party and I'm making a mess. You need to work it out ahead of time. Let's go. Let's see if we get the same flavor. Oh, it's a thin line between bitter and sweet when you're dealing with lemonade. All right, let's look. Here is where we want to make a downward arrow and check the products. So, downward arrow, we get 10 times 12. You know how we multiply numbers that end in 0. We multiply the number or the digits that are not 0. We get 1 times 12 is 12. And then we have 1 0, so we attach it to complete that product. 12 times 10 is 120. Does that equal 4 times 30? Once again, multiplying the digits that are not 0, we get 12 and attach 1 0 to complete our answer. Guess what? Yes. We can expect the same flavor. So go right ahead and increase your recipe. You won't make a mess. You'll just prepare for more guests. So 12 scoops with 30 cups of water, go for it. You'll be all right. and it'll be good. Look and see. This is how we can work it out, all right, on paper without actually purchasing and making a mess. Okay, now we're going to look at another type of problem, and I'll leave that one up because the other ones, we're not going to have a story around it. We'll just determine whether we have a proportion or not. So we want to write yes if they're equal, if the products are equal. Then we have a proportion. Okay? If the products are not equal, then the answer is no. Okay? So let's do some comparing. I'm going to compare 72 over 81. Is that equal? Is it a proportion to 7/9? Several ways to look at this, of course. All right? And I'm going to just lean over so I can block out some of that glare. 72 over 81, does it form a proportion with 7/9? Ah, I see. Oh my God, I see a way of working this one out. What I could do, I can actually simplify this. I could simplify this particular fraction and then compare it to my 7/9. So there's several ways of doing this, and this is the way I choose because I definitely see a 9 here and I see a 9 here. So let's divide out that common factor of 9. 81 divided by 9 and 72 divided by 9. Okay? 72 divided by 9 is 8. Oh, and 81 divided by 9 is 9. So now I'm comparing 8/9 to 7/9. And boy, oh boy, isn't that easy? So, do we have a proportion? Are they equal? No, I don't think so. 8/9 does not equal 7/9. If you don't believe it, cross multiply and find out. 8 times 9 is 72. And 9 times 7 is 63. So they do not equal. So we do not have a proportion in this example. So the answer here is no. It's a big no. Give you a moment to digest that. First thing we did when we looked at 72 over 81 and we compared to 7 over 9, I wanted to reduce this fraction so I can see what it looks like in its simplest form. I knew that 72 divides 9 evenly and 81 divides 9 evenly. 72 divided by 9 is 8. 81 divided by 9 is 9. Now I can simply compare 8/9 to 7/9. Whenever you have the same denominator, students, all you got to do is look at the numerator. When you look at the numerator, 8 is greater than 7, so therefore, nope, they're not equal. We are comparing also 63 to 72. Nope, they're not equal. Not equal. All right, so we do not have a proportion. All right, let's look at a different one. And I'm going to compare this particular. In one class, 4 of every 12 students have braces. And then I'm going to compare it in another class. 5 of every 15 students have braces. I'll leave that one up. So this particular comparison, we have 4 of every 12 students. So we're going to look at braces over students, total students. So 4 out of every 12 students have braces. And we're going to compare that to 5 of every 15 students in a different class have braces. Are these ratios equivalent? Are they equivalent? 4 out of 12, is that equal to 5 out of 15? That's the big question. If the answer is yes, then they're proportional. If the answer is no, then they're not proportional. Okay? So let's look and compare. With this particular one, I would reduce. I would reduce this fraction. I would reduce this fraction and then compare them. I see that I can divide out the common factor of 4 here. 4 in my numerator and the denominator. Divide out the 4s. I get 1/3. Is that equal to, that's the question. Here, 5 out of 15, I can divide out the 5 and divide out the 5. As long as I do the same thing in my numerator and denominator, I'm good. I get 5 divided by 5 is 1. 15 divided by 5 is 3. Interesting. My 4 out of 12 and my 5 out of 15 form a proportion because they are equivalent ratios. Both reduce down to 1/3. So the answer here is yes, they are equal. Okay? And they are equivalent. Let's look at another scenario. I love ratio and proportions. Okay, here's another one. In one class, okay, in middle school, 1 out of every 12 students has a birthday in June. So we're going to look at the students and total students. Well, let's look at birthdays to students. Birthdays to students. That's what we'll do. So 1 out of every 12 students, so 1 out of every 12 students has a birthday in June. In a class of 26, okay, 26 students, oh, there are 3 students with a birthday in June. Are these ratios equivalent? So 1 birthday out of 12 students, 1 birthday in June out of 12 students, 3 birthdays in June out of 26 students. Are they equivalent? Are they equal? If the answer is yes, then we have a ratio. We have a proportion. If the answer is no, we don't have a proportion. Okay, so let's look. Here I can reduce my 3. No, I can't. Nope, this does not reduce here. This one's already reduced, so I will check for my other strategy. I will cross multiply and see if I get equivalent products. Here I get 26. 26 times 1 is 26. Here I get 12 times 3 is equal to 36. And the answer is no. Nope, we don't have a proportion in this situation because they are not equal. Okay? So those ratios do not form a proportion. All right, here's another. If we think we've got the answers, let's look at a different type of problem here. I want to write a ratio, excuse me, that's equivalent a ratio that equals 12 over 30. I want to find a few ratios that are equivalent to 12 over 30. And I'm going to use several numbers from a number bank. And the numbers are as follows. I can use the number 2, 4, 5, 6, 10, 15, 24, and 60. So those are the numbers that I can use when I create a ratio that is equivalent to 12 out of 30. Okay? So here is how I would work it out. I would say to myself, okay, I can use that 60 if I multiply my denominator by 2. I'd have to do the same thing to my numerator. And 12 times 2 is 24. So already I've used the 60 and the 24. Okay? So an equivalent ratio would be 24 over 60. All right, now let's look at that same problem, 12 over 30. And using some of the others, I'm going to go with 2. I'm going to use that 2, and I'm going to put the 2 in my numerator. But how did I get from 12 to 2? I divided by 6. I can divide my denominator by 6 and get what? 30 divided by 6 is 5. So I can use the 2 and the 5. So 12 divided by 6 is 2. 30 divided by 6 is 5. So another ratio that's equivalent to 12 out of 30 is equal to 2/5. I'll put a circle around it. Okay? Now, another one that I can use, I can use the 10, even though I can divide 10 here. I can't divide 10 in my numerator evenly. I don't think I'm going to use the 15 either. I can divide 15 here, but I can't divide 15 there. But I can use, we use the 2, we use the 6. Let's try for 6. Let's try for 6, this 6 right here. So I can rewrite my original 12 out of 30. And then let's put is equivalent to 6 out of how many? What did I do to the 12 to get 6? I divided by 2, divide by 2, and I get 15. So I've used the 6 and the 15 to get an equivalent ratio. All right, let's try for the 4 and the 10. Can we do it? Oh, yeah. So looking at my original again, 12 out of 30 is equal to, say, 4. Let's see, what did I do to the 12 to get 4? I divided by 3. Divide by 3. And I get 10. So here we've used the 4 and the 10. All right, so I've used all of the numbers in my number bank to create equivalent ratios with 12 out of 30. Does that make sense? That is so cool. Creating equal ratios by performing the same operation in your numerator and your denominator. Same operation, numerator and denominator. Same operation, numerator and denominator. Same operation, numerator and denominator. Whether you're multiplying or dividing. Okay? Any questions? If you have any questions, feel free to text them to us. And we'll see that you get your answers. All right. Okay, we're going to look at some pairs of ratios and see if they are equivalent. If they are, they will form a proportion. If not, the answer is no. So we're going to see if we have a proportion or not. The question is, proportion? Yes or no? Yes if the products are equal. No if the products are different. All right, let's look at a few. 1/2. 50 over 100. Number 2. 10 over 20. 30 over 40. Number 3. 4 out of 12. 6 out of 80. 6 out of 8. Number 4, 42 out of 6, 504 out of 72. Next one. 9 out of 11. 63 out of 77. 6, 72 out of 27 compared to 8 out of 3. Okay, I think we'll stop there. You need to determine if we have a proportion, yes or no. We have different strategies we can use. Let me just refresh your memory. We can cross multiply. If these products are equal, then we have a yes. Okay? These numbers, I should really just put the number symbol here. Then the answer is yes. If they're not equal, then the answer is no. Okay? We can also reduce we can reduce and then cross multiply and then compare. If the numbers are not equal, then the answer is no. Okay? We can also so these are our strategies. We can also get a common denominator. Get a CD and not the musical kind, although math is music to my ears. We can get a common denominator and compare the numerator. Okay? So with those hints and tips and strategies in mind, go ahead and tell us if we've got a proportion or not. Okay, I'll give you a few minutes to work on them, and then we're coming back to see just how well you've done. One more minute, and then we're coming in. Alrighty, let's go. By the time we get to number 4, we need a real strategy to work that one out. So let's go with number 1. 1/2 compared to 50 out of 100. Did you find them to be equal ratios or not? The question is, are they equal? If the answer is yes, they're proportional. If the answer is no, they're not proportional. So there are a couple ways we could work it out. We could reduce the 50 over 100. Try to work it out and see what you can do with that. I know 50 divides 50. If I divide 50 by my numerator and divide 50 by my denominator, I will get 50 divided by 50 is 1. 100 divided by 50 is 2. When I compare 1/2 to 1/2, the answer is yes. They are proportional because they are equal. So number 1, the answer is yes. Number 2, we are comparing 10 over 20 to 30 over 40. Are they proportional? Well, I can divide out and see. Okay, if I divide here, I can divide 10 in my denominator and divide 10 in my numerator. I will get 1 over 2. 10 divided by 10 is 1. 20 divided by 10 is 2. Now the question is, are they equal? Here I have 30 over 40. I can also divide 10 by chance. 10 in my numerator and my denominator. And I get 30 divided by 10. That's 3. 40 divided by 10 is 4. I'm now comparing 1/2 to 3/4. At this point, you might still ask yourself, are they equal? It's simply, all I have to do is cross multiply to see. I get 4 times 1, which is 4. Is that equal to 3 times 2, which is 6? The answer is no, no, no. The answer is no. Number 2 are not proportional. The answer is no. Number 3, I have here 4/12, and I'm going to move it down so we can have more room. 4/12 compared to 6/8. Are they proportional? Are they equal? That's the question. Well, how would I solve this one? It's not too bad to cross multiply and see to get a quick answer. 4 times 8 is 32, and 6 times 10 is 60. The answer is no. Not proportional. Number 4. Woo! Here we are, guys. Here we are. How do we handle this one? Number 4. I would probably try to reduce that 504 with that 72. I would do that quicker than anything else. And I'm just checking. I declare I'm checking. I'm going to check it so much until I'm going to erase our 1, 2, and 3 over here so I can have room to work out number 4. 504 over 72. I'm going to check to see if, well, I could check to see if 72 goes into 504. I could do that, but I'm going to check a number that I know definitely goes into both. And yeah, I'm going to be a chicken, and I'm going to say I'm going to divide the numerator and the denominator by 2. 504 over 72, divide both by 2. Be safe. I'm going to be safe here. 504 divided by 2 is equal to 504 divided by 2. 2 goes into 5. 2 times 2 is 4. Bring down 10. 2 goes into 10 5 times. 5 times 2 is 10. Bring down the 4. 2 goes into 4 2 times. I come up with 252 over 72 divided by 2. I'm going to do this the long way, just to make sure we have everybody on board. 72 divided by 2. 2 goes into 7. 3 times 2 is 6. Come down. Oh, I can see it right now. Bring down my 12. 2 goes into 12. 6 times 2 is 12. No remainder. So we have 36. That helped a little bit. So we came down from 504 over 72 to 252 over 36. Let's see. I know that 252 divides out 3. It divides 3. I know that because any number, you can check it to see if it divides 3 by adding up the digits. 2 plus 5 is 7, and plus 2 is 9. 3 goes into 9, therefore 3 goes into 252. When I add 3 plus 6, I get 9. 3 goes into both of those numbers. As a matter of fact, I know now that 9 goes into both. But I'm going to take it slow to make sure everybody's on target. So let's divide out a 3 in the numerator and a 3 in the denominator and see where we go. All right, now we have 252 divided by 3. 3 goes into 25 8 times. 8 times 3 is 24. Subtract, bring down my 1, bring down my 2, which is 12. 3 goes into 12 4 times. 4 times 3 is 12. No remainder. So now we get 84 over 3 goes in 36 divided by 3, boys and girls and students, is equal to 12. So now, it's becoming so clear and plain now. Whew, and boy, what a lot of work. Just to reduce the 504 over 72. I'm definitely seeing, okay, I'm going to take it. I'm going to take it slow. I see a 12 being divided by 12 and a 12 being divided by 84. So let's go for the 12. 12 divided by 12 is 12, and 84 divided by 12 is let's see, does 12 go into 84 evenly? 7. Let me see, 7. We get 14. Yep, 7 times. So we get 7 over 1. Whew, that was a lot of prepping. So 504 over 72 actually is equivalent to 7 over 1. So we can go back, create that equivalent, and even replace it temporarily with 7 over 1. So I'm going to look at 42 over 6. Is that equivalent to 7 over 1? Oh my, look at this. Wow. If I divide out the 6 in the numerator and the denominator here, guess what I'll get? Dividing out the same number, guess what I get? 42 over 6 is equal to 7. 6 over 6 divided by 6. 42 divided by 6 is equal to 7. 6 divided by 6 is equal to 1. Now I can compare 7 over 1. Guess what, students? We go back to the original problem. 42 over 6 is proportional to 504 over 72. So the answer to number 4 is yes. They are proportional. Woo! That's number 4. Let's look at number 5. 9 out of 11, or 9 over 11, how does that compare to 63 over 77? I think what I'll do first is I will reduce, because I see a common factor here. 63 over 77, I see a 7 here, and I see a 7 here. And that 63 over 77 reduces to I can divide out a 7 here, divide by 7, and I get 9. Now I can compare that to 9 over 11. Oh my goodness! Do you see that? They are absolutely equal. Beautiful. So the answer to number 5 is yes. They are proportional. Number 6, 72 over 27. How does that compare to 8 over 3? I'm going to, do you see a common factor between 72 and 27? I do. I see a 9 here, and I see a 9 here. So I'm going to divide out the 9 in my numerator and divide out the 9 in my denominator. 72 divided by 9 is actually equal to 8. 27 divided by 9 is 3. How does 8/3 compare to 8/3? Are they equal? You better believe it. You better believe it. They are proportional. Okay? All right. So this lesson was pretty much more mechanical than anything else. Okay? We did start out with the lemonade and being able to predict what's going to happen based on the ratio. I love ratios because it allows us to put it in perspective. Put those math principles and those math skills into real life situations so we can solve problems. Okay? So, I can actually tell you, we can actually take these and actually put them right into a problem. And it would work. It would work in a real life scenario. So we are going to pause right here because what I need you to do, I need you to review this particular video to make sure you've got the skills so that you can recognize a proportion when you see it. Okay? And know that if those particular ratios are equivalent, then you've got a proportion. If they're not equivalent, then you don't have a proportion. You can't rely on it if they're not equivalent. And there were different strategies to use. Okay? Remember the cross multiplication across the equal sign? Remember there's an equal sign here, or questioning an equal sign, question mark, if they're equal. And in this case, if the answer is yes, then these two products are equal. If these two products, you can also reduce and then cross multiply. And if those two products are not equal, then you don't have a proportion. You can get a common denominator, okay? And then compare the numerators. So there's several ways of determining whether you have a proportion based on your ratios. That's why we call it ratio and proportion. Thank you so much for joining us. And I hope, once again, that you've gotten a lot out of this. Come on, y'all. Try it. Do it. Go into your classroom, whether you're in college, elementary, middle, or high, and show your teacher that I'm doing some extra work because I want to be the smartest one in my classroom. Let me just share with you a little kind of boldness that I'm starting to gain in this. I saw, and I'm not telling you, I'm telling you the truth. I saw two young ladies walking down the street, getting ready to get into the habit of doing something that they should not be even should not take part in. I was able to go to them and tell them, excuse me, do you mind if I share something with you? I am a retired teacher, and I just want to share this information with you. Don't you know what you are about to do can hurt you for life? Don't do those things. Your life is just beginning. So only do those things that's going to be productive in your life. Don't start bad habits and you won't have to break them. Do the right thing as much as you can. Form good habits. So when it's time to question what you do, you'll lean to the good side and won't have to pay consequences for doing things that you shouldn't do. Now, these young ladies picked up something and was about to put it in their mouth. I said, no, don't do it. People who are caught in those situations, they wound up in hospitals, they wound up on drugs, they wound up in a bad state. If you're free from all of that, stay free. Do you understand me? Because I want you to be the best person you possibly can be. That's why I'm doing what I'm doing. That's why you're here, so you can get on top of this. This will be one less struggle you'll have to deal with in life. And I want you to be the best. I want you to be the best in everything that you do, especially in mathematics. It all matters. We're living in a day and time where they say Black Lives Matter. Well, so does mathematics. And whatever you put in your head, it all matters. Come on now, do it because it's the right thing to do. Not because someone's looking over your shoulder, but because it's the right thing to do. Be blessed. Talk to you next time. Bye-bye now.